Hello everyone, I am Monica from the Department of Computer Science Engineering. Today I am going to present about a topic construction and working of a zinc air battery and lead acid batteries. This topic is very important because both batteries are widely used in our real life applications. So let us begin the presentation. These are the important topic I would like to discuss with you. Introduction of a zinc air battery and lead acid battery, construction and working principle of both batteries, and reactions of both batteries. We discuss about the first zinc air battery. Zinc air batteries are electrochemical batteries that use zinc metal as an anode and oxygen from the air as a cathode. They are lightweight and have high energy density and are commonly used in hearing aids, small electronics and backup systems. Here, electrochemical battery means that converts chemical energy into electrical energy by redox reaction. Construction of a zinc air battery. The main components of a zinc air battery are anode, cathode, electrolyte. A zinc metal anode, usually in powdered or porous form. An air cathode made up of porous carbon with catalytic material like manganese dioxide. An alkaline electrolyte such as potassium hydroxide separator used to prevent short circuiting. A hydrophobic membrane that allows oxygen to enter but keeps the electrolyte inside. Small air inlet holes in the casing for oxygen flow. These are the components work together to allow oxygen from the air to participate in the chemical reaction. Working principle of a zinc air battery. During zinc air battery, oxygen from the atmosphere enters through the air holes and reaches the cathode. Here oxygen gets reduced to form hydroxide ions. At the anode, zinc metal gets oxidized and release electrons. The electrons flow through the external circuit and produce electricity. The hydroxide ions combines with the zinc to form zincate. Here we can see that zinc air battery. This diagram clearly shows the flow of oxygen and the movement of ions and the releases of the electrons. Here we can see the zinc anode and the cathode and the electrolyte and the gas diffusion, which allows the battery to work efficiently. Reactions of a zinc air battery. At anode, zinc reacts with the hydroxide. It forms ZnO plus water and 2 electrons loss. Cathode reaction, O2 plus 2H2O plus 4 electrons gives rise to 4OH. Overall reaction, 2Zn plus O2 gives rise to 2ZnO. This completes the working of the zinc air battery. This reaction explains how the zinc air battery produces power. Let us discuss another battery, lead acid battery. Lead acid battery is one of the oldest and mostly widely used in rechargeable batteries. It is commonly used in automobiles, inverters, UPS systems, and solar storage applications due to its reliability and low cost. Here, rechargeable batteries means a battery that stores energy. When it gets discharged, you can charge it again. Construction of a lead acid battery. The construction includes a positive plate made up of lead oxide PbO2, a negative plate made up of spongy lead Pb, separators made up of porous materials to keep the plates apart, dilute sulfuric acid H2SO4 as the electrolyte, a strong container made up of hard rubber or polypropylene, multiple plates like positive plate or negative plate connected in series to form a cell and increase the voltage. Here we can see that the lead acid battery. This diagram shows the internal structure of a lead acid battery including terminals, plates, separators and glassmate, and liquid fill levels, minimum liquid fill line, maximum liquid fill line, fill cap, strap, etc. Working principle of a lead acid battery. The working of a lead acid battery involves two modes. One is charge and discharge. Let us discuss first during charge. Here charge is the quantity of electricity stored during or carried by particles like electrons. Both electrodes react with the sulfuric acid to form lead sulfate, or electrons flow from the negative plate to positive plate through the external circuit supplying power. Here during discharge, first the discharge meaning means discharge is the process in which the chemical energy stored in the battery is converted into electrical energy supplied to the external circuit. An external source reverses the chemical reaction. Lead sulfate converts back to lead dioxide at the positive plate and the spongy lead at the negative plate. Thus it is a reversible electrochemical system, or this is a reverse reaction make the lead acid battery a reversible electrochemical system. Here we can see the diagram about the charging process and discharging process. In charging process, charging system voltage is higher than the cell voltage. Charging circuit is driven into cell and stored chemically. Electrons current is shown in the figure. Here we can see that the positive plate lead sulfate changes the lead peroxide sulfate returned to the electrolyte. Here we can see the negative plate lead sulfate changes to the spongy lead sulfate returns to the electrolyte. Here we can see the charging system. Here we can see the electrolyte. It is made up of stronger. By return of a sulfate from the plates, hydrogen is released. Coming to the discharging process, here we can see that voltage of a cell drives current through the load discharging cell. Electrolyte become weaker by dilution from the reaction by product. Here we can see that the diagram of the discharging process, positive plate, negative plate and the electrolyte. Here negative plate sponge lead changes to lead sulfate. Positive plate lead peroxide changes to lead sulfate. Here electrolyte becomes weaker because of dilution by water created by the combustion of a hydrogen of acid and oxygen of a lead peroxide. By comparison of the both charging process and the discharging process, electron flow plate reaction, electrolyte behavior. Here the charging system is moving from the positive plate to negative plate and enters into the charging system. Here in discharging process, negative plate electrons enters into the positive plate electrons enters into the negative plates and it loads and it becomes weaker. Chemical reactions of a lead acid battery. The reactions are at anode lead react with the SO4, it gives rise to PbSO4. At cathode reaction, PbO2 plus 4H plus SO4 plus 2 electrons gives rise to PbSO4 plus 2H2O. Overall reaction, Pb plus PbO2 plus 2H2SO4 gives rise to PbSO4 plus 2H2O. When lead oxide react with the sulfuric acid, it forms PbSO4. This explains the working of the lead acid battery. Here we can discuss about the advantages and disadvantages of the both batteries. Zinc air batteries are lightweight and high energy, commonly used in hearing aids and small electronic devices, etc. Lead acid batteries are reliable and used in the automobiles and power storage inverters, UPS systems, etc. Both plays a major role in today's technologies. Thank you for watching my presentation.